Hi, my dear students, welcome to our electromagnetic theory course. In today's class, we will discuss about differential elements and gradient of a scalar in different coordinate systems. In previous classes also I explained about these differential elements along unit vectors, differential elements dl, ds and dv. Okay. I also uploaded a video on these differential elements along unit vectors, differential elements dl, ds, dv. What are the differential elements in different coordinate systems? Basically, to analyze our electromagnetic field parameters, we require the knowledge of coordinate systems, orthogonal coordinate systems, that is Cartesian, cylindrical and spherical coordinate system. What are the elements in the Cartesian, cylindrical and spherical coordinate system? In Cartesian xyz, and cylindrical rho pi z, and spherical r theta phi. Now let us consider a Cartesian coordinate system. Like this. This is okay. Now take like this. It is what? It is our x axis, y axis and z axis. It is our origin. Then represent a point in the space by using this Cartesian coordinate system. Now by joining this, okay, no need to join this one actually. Okay, here like this, okay, and what about this? Here we have a point, let us say this is point P, and take another point, this as P dash. Now let us consider point P is represented as x comma y comma z, and assume that the distance between point P and P dash is very small. In that case, P dash is represented as what? X plus dx plus y plus dy plus z plus dz. Okay, the distance between P and P dash is given by, that is dl is equal to pp dash. That is displacement. Let us say displacement means what? If you move from this point to this point, let us say object is here, okay. If this object is moved from this point to this point along x direction, it is displaced by an amount of what? Dx. Along y direction, it is displaced by an amount of dy. Along z direction, it is displaced by an amount of dz. These dx, dy, dz are called as differential elements in Cartesian coordinate system. What are the differential elements in Cartesian coordinate system? Let us consider Cartesian coordinate system. In Cartesian coordinate system, elements are x comma y comma z. Unit vectors are ax, ay, az. Then differential element along x direction. Differential element along x direction is given by dx ax. Along x direction is given by dx ax. Similarly, along y direction, differential element along y direction is given by what? That is, if it is if it is along x direction dx ax, then along y direction it is what? dy ay. Next, differential element along z direction, differential element along z direction is given by, that is what? dz az. Then what about the displacement from p to p dash? That is given by dl bar. That is given by what? dl bar. Here we consider individually along x axis, along y axis, along z axis, but we require what? A total differential displacement from point p to p dash is given by what? That is nothing but along x axis it is dx ax, along y axis it is dy ay, along z axis it is dz az. Coming to cylindrical coordinate system, what is cylindrical coordinate system? In cylindrical coordinate system, COS stands for coordinate system, and elements are what? Rho, pi, z. What is rho? Radius of cylinder. What about the range of rho? The range of rho is 0 to infinity. What about the range of the x, y, z? Let us say x, y, z. These are varied from what? Minus infinity to plus infinity. Okay, if you see, there is a similarity. Suppose let us say x is varied from 0 to infinity. In that case, within this range, minus infinity to plus infinity, that is what? In that range, we will get what? 0 to infinity. That's why along rho direction, differential element along rho direction, differential element along rho direction is given by what? It is similar to x. Okay, for the x it is dx ax, for the rho it is d rho a rho, for the rho it is d rho a rho. Similarly, differential element along pi direction, what about this one? It is nothing but what? It is rho d pi a pi. Why it is like this? We will see later. And differential element along z direction is given by, differential element along z direction is given by what? dz az. This is differential element along rho direction, along pi direction, along z direction. It is same as in Cartesian coordinate system. Okay, of course, in Cartesian coordinate system, a vector is represented as what? Along x axis ax, along y axis ay, along z axis az. Then the representation of vector is like this. Whereas in cylindrical coordinate system, a vector can be represented as, I am writing here, in cylindrical coordinate system, a vector a bar can be written as a rho, a pi plus az. Now we need to discuss this one. Why we are getting this additional factor rho? Okay, of course, differential element along pi direction means what? For pi we will get a d pi a pi. There is no problem, but here we got an additional factor rho. Of course, we can remember differential element along pi direction like this. This pi is angle made by whom? Rho. Okay, now we will see how we will get differential element along pi direction as rho d pi a pi. Now we will see how we are getting differential element along pi direction as rho d pi a pi. Let us draw that cylindrical coordinate system. What is cylindrical coordinate system? In cylindrical coordinate system, the elements are what? Rho pi z. So let us take this as your x axis, and it is your y axis and z axis. What are the elements in cylindrical coordinate system? Rho pi z. What about the rho? Rho is the radius of the cylinder. Z is reference axis. Okay, take this as a reference axis and let us draw a cylinder of radius rho. Here to here radius is what? Rho. Okay, and this is our cylinder of radius rho, okay. Rho is also called as what? A radial distance. That means like this. Okay, radial distance like this. Here I am considering this part only. It is what? Rho, and it is making an angle pi with x-axis in anti-clockwise direction like this, and z is same as in Cartesian coordinate system. Of course, we need to find what? Differential element along pi direction as what? Rho d pi a pi. This can be obtained a basic definition of angle. You might be studied in your 10th class, that is angle is equal to what? Arc length by, here it is a, here a, arc length by radius, arc length by radius. Now substitute angle, okay, substitute, here we have some equation. What is angle in this case? That is our pi. And what is length? Arc length, so that is, let us say some L, and radius is given as what? Rho. Now tell me, when this angle will be changed? Basically, here I have, here to here I have arc length of, let us say L. Okay, I am redrawing that one like this. So it is your x-axis. This is a rho, and it is making an angle pi like this. And if I take same radius, this one radial component, radius is same. Okay, the radius of cylinder doesn't change in this case. Okay, so that is rho. And in this case what? We require the variation along the pi direction, means in this direction. Suppose pi is shifted by what? A small displacement, that is phi plus d pi. I consider like this, that is pi plus d pi. In this case, for the pi, means for this blue one, arc length is L, whereas in this case, this black one is greater than this blue one. That means here for phi plus d pi, I will get what? L plus dl. That means what? If this angle changes, this L changes, but there is no change in the radius of the cylinder, that rho, that is fixed. Okay, radius means, okay, for the given cylinder the radius is fixed. Here in this case we require the differential element along pi direction, means in this direction. Okay, that means it is shifted by what? Some pi plus d pi. If pi is shifted by pi plus d pi, we can clearly observe that this is a smaller one, whereas this is greater than this one. That means phi becomes, if pi becomes phi plus d pi, L becomes L plus dl. Means what? If there is a change in the angle, that means it may be increased or it may be decreased. In that case what? Here we consider the increment case, that is d pi equal to what? dl by rho. So that's why dl equal to what? Just dl, that means a differential element along a pi direction. It is not entire displacement. dl equal to what? Rho d pi. Now write down differential elements along rho direction, pi direction and z direction. Now differential elements in this case are given by differential elements along, let us take this common one, that is differential elements along rho direction. Differential element along rho direction is nothing but what? Rho direction is nothing but what? d rho. It is displacement along rho direction. Okay, that's why we need to write a unit vector, that is a rho. And a differential element along pi direction. Differential element along pi direction is given by what? Just now we derived. It is the displacement or else differential element along pi direction. That much of, okay, this much of distance is shifted along pi direction, so that's why rho d pi into a pi. And last one along z direction, the z is same as in Cartesian coordinate system. Here we will get what, that is what, dz az. So these are the differential elements in cylindrical coordinate system. That is what dl bar is equal to what, along rho d rho a rho, along pi is angle made by rho, so that's why this d pi is multiplied by this rho d pi a pi, whereas z is same as in Cartesian coordinate system. This is dz az. It is differential displacement along it is the entire, that is total differential displacement in case of cylindrical coordinate system. Now can you write differential elements in spherical coordinate system? For that, what you required, here I am writing along pi direction, we have differential element is rho d pi a pi. With the help of that one, we can write what, differential elements in spherical coordinate system. For spherical coordinate system, COS stands for coordinate system. Please take it as coordinate system. Okay, differential element along r direction, differential element along rho direction we consider as what, rho d rho a rho. Similarly here, differential element along r direction, that is a differential element. Okay, this is taken common to all these elements, that is r theta pi along r direction. It is taken as what, tell me, it is just as radius of cylinder rho here, but radius is what, r, that is dr a r. Along theta direction, in case of spherical coordinate system, what is theta? Theta is angle made by, I am drawing here only, okay, so that is theta is angle made by this r with z axis, where r is the position vector of the point P. This is nothing but radius of the sphere. In the previous case, we considered what, differential element along pi direction means what, this pi is angle made by rho, so that's why that is multiplied by rho. In this case, this theta is angle made by r with z axis, that's why it can be taken as what, r d theta a theta. And differential element along pi direction, what is this one? In this case, pi, here we have pi, but here rho need to be taken as what, r sin theta. If it is projected on z axis, z equal to what, r cos theta, already we discussed. If it is projected like this, it is projected in xy plane like this, that is what, r sin theta. This r sin theta is making an angle pi, so that's why differential element along pi direction is d pi into a pi, but it should be multiplied by r sin theta, because that angle pi is angle made by r sin theta. Okay, so this is about the differential elements in spherical coordinate system. Now total differential displacement, that is dl, here we consider individually along r direction, theta direction, pi direction. Then total displacement means that is dl bar, that equal to what, dr a r plus r d theta plus r sin theta d pi. Here I forgot to write unit vector, please write down this unit vector, r d theta a theta plus r sin theta d pi into a pi. And what about the vector representation? Here it is component along r direction into ar, theta component into theta, and pi component into pi. Means in case of the spherical coordinate system, we can write, we can represent a vector in spherical coordinate system, that is a bar equal to what, ar plus a theta plus a pi. Okay, this is all about differential elements, that is dl in Cartesian, cylindrical and spherical. By summarizing all these, we can write differential displacement in spherical, cylindrical and Cartesian can be written as dl bar is equal to what? dl bar is equal to what? One means, let us say, Cartesian coordinate system. Okay, in Cartesian, for Cartesian, okay, for Cartesian coordinate system, dl bar is equal to what? That is dx ax plus dy ay plus dz az. Please remember this one. It can be helpful to derive our gradient of a scalar function, as well as this can be helpful to derive the relationship between our electromagnetic field parameters, are nothing but E equal to minus del V. Basically, these are electric field parameters. One is electric potential and another one is electric field intensity. Here you have what? Gradient. Now we will discuss this gradient of a scalar function. Before entering into that gradient of scalar, write down this dl bar in cylindrical and spherical. Of course, we can easily write this dl bar in cylindrical also. What is the first element? First you need to remember elements, that is rho pi z. What is the element along rho direction? D rho a rho. Okay, if you have an angle, take care of this angle. If there is no angle, then we can write directly write, if it is rho d rho, if it is z dz. Okay, if there exists a angle, in that case only we need to write like this. For the here angle is d pi into a pi, but this angle is made by rho, that's why rho into d pi a pi plus last element is dz az. Coming to the spherical coordinate system, in spherical coordinate system we can write this one like this, that is, in spherical we have what? Elements are r, theta, pi. For spherical coordinate system, dl bar is equal to what? dl bar is equal to what? First one is what? R. If it is r, dr ar, because it is not angle. And we have remaining two, that is theta and pi r angles. What about theta? For theta, d theta into a theta, but it is angle. If it is angle, it is multiplied by r, since theta is angle made by r. Similarly, last element, that is pi, for pi d pi a pi, as it is angle, we need to consider what? Product multiplication factor like this, that is r sin theta. Let us take here, it is 1 into something. Let us write like this, 1 into dx plus 1 into dy plus 1 into dz. In this case, these differential elements are multiplied by 1 1 1. So for Cartesian coordinate system, h1 equal to 1, h2 equal to 1, h3 equal to 1. Let us take like this only. With the help of that h1, h2, h3, we can derive gradient, divergence and curl in any coordinate system. So that's why please take like that. And here, what about this one? Here the multiplication factor of d rho is 1, and here in case of cylindrical coordinate system, h1 is 1, h2 is rho, and h3 is what? h3 is also 1. Whereas in spherical coordinate system, what about this one? Here 1 into dr, that's why h1 is 1 and h2 is what? R, and h3 is what? R sin theta. Please remember these things. Okay, now we will discuss about that gradient of a scalar function. Please note down these things. Okay, these h1, h2, h3 are very helpful to derive our gradient, divergence, curl in different coordinate systems. Now we will move on to gradient of a scalar function. Gradient of a scalar function. What is meant by gradient? Gradient of a scalar field or scalar function. Scalar field. What is meant by gradient? Basically, gradient of any scalar gives what? A vector. Okay, gradient of any scalar gives what? a vector. Here it represents what? It represents the maximum space rate of change of the scalar field. Maximum space rate of increment, we can say increment, maximum space rate of increment of a scalar field. We will see how we can say it is a maximum space rate of we will see how this gradient represents maximum space rate of increment of scalar field by deriving the formula for this gradient. Now let us take two surfaces. Okay, so one is like this, that is, and another one is like this. Let us assume these are having equal potential at each and every point. For this one I am taking, this is having a potential at each and every point is having V1 and here V2, and take, okay, it is a equipotential surface, that is V, and assume this V1 and V2 are separated by a small distance. Here it is P1 and it is P2, and the distance between P1 and P2 is nothing but a small displacement, that is dl bar, a small displacement dl bar. Okay, now the difference between this V1 and V2 is taken as the difference between the voltage. Here I consider two surfaces. First one, V1 is like this, and V2 is like this. These two are separated by a small distance like this. Okay, at each and every point on these surfaces, at each and every point potential is same, that means scalar functions are same. Here I consider a scalar field like this, that is V, okay, for the first surface V1 and for the second surface V2. Now I can write the difference between these two, that is the potential difference between these two, that is V1 V2, or else the difference between these scalar fields is taken as dV. Okay, here I consider 3D plane, means we should write, if it is one dimensional case, we can write like this, that is dou V by dou X into dx. But as it is 3D, it is X, Y, Z. We need to consider the remaining two also. We need to add all these three, then we will get this dV. That is difference in the potential of this V1 and V2. That is dou V by dou X dx plus dou V by dou Y into dy plus dou V by dou Z dz. Now I can write this one by using a vector dot product like this, or else in vector dot product form I can separate these things like this, that is dou V by dou X along x direction I am taking like this ax, along y direction that is dou V by dou Y ay, means I am changing this one into a vector notation, that is dou V by dou Y ay plus dou V by dou Z az into dot. Here what I did, simply I multiplied this dou V by dou X with ax, similarly multiply this dx with ax, dy with ay and dz with az, like this, that is dx into ax plus dy into ay, dy into ay. Remove this surface. Okay, basically it is V, dy into ay plus dz into az, it is our x axis, potential V1 V2, dz az, and from this I assumed this one as some g, and here dot product I can write like this, that is ax dot ax is 1, ax dot ay gives 0. That's why I will get what? Dou v by dou x into this dx plus dou v by dou y into dy plus dou v by dou z into az. If you didn't understand this, please refer the dot product. Okay, please refer the topic dot product. I already uploaded a video on the dot product and cross product. And what is this? It is nothing but what? Differential displacement in Cartesian coordinate system. That is nothing but what? dl bar. What is this dl bar? Is nothing but what? A displacement from point P1 to point P2. Of course, here we have a surface like this, that is V. Okay, on this surface V is same at each and every point. These are the level surfaces. At each and every point potential is same. Okay, on this one V1 is same, on this one V2 is same. If I consider another one, okay, that is also V. The type of surfaces are called as equipotential surfaces, or else we can call that surfaces as level surfaces. Okay, now I am writing this one like this. It is dot product. We know that for the dot product we can write this as G. G means that is magnitude. Okay, that is mod G into mod dl into cos theta. As it is dot product, we can write like this. Then I am sending this mod to this side. Okay, that means this dl to this side. I am writing like this. That is what? dv by dl is equal to what? G cos theta. G cos theta. What is this G cos theta? What is G cos theta? We need to see the G cos theta on this diagram. Now, if you represent this dl on the diagram, what is dl? What I said, dl is nothing but what? A displacement of differential displacement between point P1 and P2 like this. That is dl is like this. And here what you required? If I move from point P1 to P2, there is a possibility of what? Change in the potential from V1 to V2. Okay, on this surface, the potential is same, that is equal to what? V1, and on this surface we have the potential V2, and here potential on this surface is V. Okay, the potential difference between these two, that is, let us say it is a potential function, that is electric potential function. In that case, potential is given by what? Potential difference is given by what? dV. The dV is derived like this. And if you move from P1 to P2, this V is changed, or else the scalar function is changed with respect to this displacement. That change can be written as what? dV by dl as like this, that is G cos theta. Of course, here we consider what? Magnitude. Okay, that means the change in the magnitude of this one depends upon what? The G and the angle between, here we have what? G dot dl, that is dV. That means this basically dV depends upon what? dV, and this G basically it is a gradient. Okay, if you see what we consider, G as dou v by dou x ax plus dou v by dou ay plus dou v by dou z az. Clear? The change in this one dV depends upon what? This gradient, that means the magnitude of this gradient and angle between the G and dl. Now tell me, it is your dl, let us take our G as like this, the angle between, okay, the angle between G and dl as taken as, I consider the angle between G and dl as theta. Okay, I represented G like this, and this is theta, it is your dl, it is your point P1 and P2. It is G. The angle between G and theta, the angle between G and dl is, I consider as what? Theta. If theta is 0, then what happens to this dVl? That equal to, basically the value of this dV by dl means what? The change in this V with respect to L means space rate of change of V, or else rate of change of this scalar function depends on what? Magnitude of this G as well as direction. Theta means direction. Now, it may be maximum or minimum depending upon this theta. If theta equal to 0, when it becomes maximum, if theta is 0, we will get maximum, that is dv by dl equal to what? G cos theta. If theta equal to 0, that gives what? Dv by dl becomes maximum. Of course, it is magnitude of dv by dl, that is G. And if theta equal to 90 degrees, then dv by dl becomes what? Minimum. Means what? 0. dv by dl equal to what? Minimum 0. That means this G, what is our G? What we consider as G? That is, G is nothing but what? G equal to dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az. Basically, it is the gradient formula in Cartesian coordinate system. What this gradient represents? If theta equal to 0 means what? dl and G both are in same direction. That means if displacement is along the gradient direction, then you will get dv by dl as maximum. Means gradient of any scalar function v represents what? Its magnitude and direction. Of course, it also represents what? The maximum space rate of change of scalar potential. Scalar function. It represents what? Maximum space rate of change of a scalar function v. Okay, that means if displacement is along this gradient direction, then you will get the maximum change in this v. Let us take an example here. Let us say here we have some, okay, let us say like this. I have two objects. Okay, here at the blue one I have 0 degree centigrade temperature. Let us say here 1000 degree centigrade temperature. If I move in this direction, means, okay, if I move in this direction, that means if the displacement is, it is a gradient, okay, it is changing with respect to what? A distance. If it is coming in this direction, that means what? Temperature is increasing. Means here it is displaced from this point to this point. Means what? Displacement is along what? That is dl. That means the movement of this object is like this, that is dl. The angle between the displacement and gradient is also same. That means in this case we will get maximum temperature for this object. Suppose if this object is moving perpendicular to this one, perpendicular to the G, in that case we will get the minimum one. Means what? Let us say here, okay, let us say here I have a temperature 0 degree centigrade and another end of the, okay, another wall. Here I have two walls. In this side one wall and on that side another wall. Okay, let us say there is a temperature difference between this one and that one. On that side I have maximum temperature, here minimum temperature. If I move in this direction, that means it is displaced, okay, it is displaced. Then the variation, let us say temperature is increased. Means what? It is the movement is parallel movement. It is one wall and another wall. It is both are in parallel. If it is moving like this, perpendicular, means theta is 90 degrees. In that case we will get 0. That means what I want to say is simple thing. Gradient of any scalar function represents what? Maximum space rate of change of the scalar function. Okay, of course here this v is varied with respect to what? This x. Space means what? A distance. Okay, in this class what we have discussed, that is differential elements and a gradient of a scalar function. The gradient is given by what? G equal to dou v by dou x, ax plus dou v by dou y, ay plus dou v by dou z. Of course, we can write gradient formula in cylindrical coordinate system and a spherical coordinate system. We can easily write that formula in cylindrical and spherical coordinate system by using h1, h2, h3 parameters. By using h1, h2, h3 parameters. Okay, from this we have a gradient like this, that is g equal to dou v by dou x, ax plus dou v by dou y, ay plus dou v by dou z. What is this gradient? Gradient basically represents the maximum space rate of change of the scalar function in its incremental direction. Let us say it is increased from v1 to v2. We consider difference as what? v2 minus v1, that is difference is dv. Basically we are considering this direction is incremental direction of that potential function v. Now here we have the gradient formula in Cartesian coordinate system. In cylindrical coordinate system we have, in cylindrical coordinate system, or else generalized formula, gradient of any function, that is del f, that is g means gradient, is given by 1 by h1 dou f by dou u au plus 1 by h2 dou f by dou v av plus 1 by h3 dou f by dou w a/w. Now substitute that h1, h2, h3 in this expression. We will get what? The gradient formula in different coordinate system. Suppose let us say for Cartesian coordinate system. For Cartesian coordinate system. For Cartesian coordinate system, COS means coordinate system. Del f for Cartesian coordinate system. H1 equal to what? 1 and h2 equal to what? 1, h3 equal to 1. Substitute in this one. UVWR x, y, z means elements in the given coordinate system. Now we can write gradient formula, that is del f is nothing but what? Del f or del v we can take. Okay, let us take del f. Del f is what? We can take any scalar function, not only v. Del f equal to what? Del f equal to what? Dou f by dou x, ax plus dou f by dou y, ay plus dou f by dou z, az. Similarly, for cylindrical coordinate system, what about this? That is h1 equal to 1 and h2 is rho and h3 is 1. Substitute in this one. Please give it to star. Okay, then we have what? Del f equal to what? That is dou f by dou rho, a rho plus 1 by rho dou f by dou pi a pi, and last one is same as in Cartesian coordinate system, dou f by dou z, az. Okay, for this space problem I am writing the third one, spherical coordinate system. For spherical coordinate system, h1 is what? 1 and h2 is what? r and h3 is what? r sin theta. Here I am directly writing that gradient formula in spherical. Del f equal to what? 1 by h1 means 1 only, that is dou f by dou r ar. And last one, second one, that is 1 by h2 means what? 1 by r dou f by dou theta a theta. And last one is what? 1 by h3, that is 1 by r sin theta dou f by dou pi a pi. Of course, we discussed these gradient, divergence, curl in one lecture. I also uploaded that lecture in YouTube, but here I discussed because in that lecture we have some noise problem, so that's why here I had written gradient formula in different coordinate system. Of course, we can write divergence and curl by using this h1, h2, h3. Okay, this is all about today's class. We will meet in next class. Thank you.